All right, now I will prove this statement where the domain is the natural numbers. I'll prove it by induction. So the proof will start with the base case. Base case is p of 0, so I want to prove this fact here, that 2 to the 0 is 2 to the 0 plus 1 minus 1. Often the base case is what we say is call a trivial, or it's really simple. Okay, so let's see, let me prove that. So starting with the left-hand side, 2 to the 0 equals 1, which equals 2 minus 1, which is equal to 2 to the 0 plus 1 minus 1. Okay, that's the base case. Now I'm going to assume P of k. For the inductive step, let's say, assume P of k is true. Well, what is P of k? P of k is 1 plus 2 plus 2 to the k. I did leave out this term, but it's implied in there. Okay, that's equal to 2 to the k plus 1 minus 1. So assume that. So we're assuming that this equality is true, that we have this equality. Okay, so then 1 plus 2 plus 2 to the k plus 2 to the k plus 1. Now you think, okay, what is that equal to? Right, now we're assuming that this is equal to that, right? And notice that this thing I have circled in blue here, notice that that is exactly that. Right, so our assumption tells us that the thing in blue is equal to 2 to the k plus 1 minus 1. So we have 2 to the k plus 1 minus 1 plus 2 to the k plus 1. Okay. Now, we're trying to get to this, trying to get to that, 2 to the k plus 1 plus 1 minus 1. All right, so now we're going to do a little thing with combining like terms. And I'll just save where I'm trying to get to so I can keep an idea where I'm trying to get to. Okay, so now I'll do a little thing with, so we have 2 to the k plus 1s, right? So think about if you had x plus x, you would say that was 2x, right? So now the x is like this. This is like our x. Right, so there's 2 to the k plus 1s. So we have 2, so we're combining like terms, 2 to the k plus 1 minus 1. And remember there's a 1 here, right? It's 2 to the 1. And when we have the same base, we add the exponents. So this is exactly 2 to the 1 plus k plus 1 minus 1. Well, that's just the same as 2 to the k plus 1 plus 1 minus 1, which is where we wanted to get to. And that is the inductive step.